Okay, so you can see what we're looking at here today is a walking trash master. The original file that you can find up on Thingiverse was titled, I'm looking on there now, it's just called Trash Walker. But it was basically a bucket that you could store things in with some cool legs, and I mean, it looked great. Been around for a couple of years. So I decided, well, wouldn't it be neat if we could just keep a lot of the look, but actually make one that could walk. So that is what we've got going on here today, and I'll show you a couple of different ways of doing it. It only requires 2 servos, inexpensive servos, to do the walking. If you decide to do the head turning, then that'll take a 3rd servo. But this one is programmed. In this case I used a Pololu 6-channel, the Mini Maestro. Of course you can use Arduino, whatever your favorite flavor is, but I prefer the Pololus. And you can also do it if you don't have programming skills and don't want to go that route. You can do a version that would work just off a servo controller. For example, this one, it's all printed in green, just has a servo controller connected to the 2 servos that are in there. So when you turn it on, if we've left enough room for everything, you can put your servo controller in manual mode, and then as you turn the knob, you control the feet. So you can make it walk any speed you want, for example. So you can walk really slow or just giddy up. Whatever you want to do. You know, these things cost anywhere from $1 to $3 or $4, so it's a very inexpensive way to control the servos. Like I say, you only need one to control both servos. There's only 2 servos in this whole project, and they're both down on the feet. If you decided you wanted to, let's move this camera a bit so I can get further back here. If you decided you wanted to do the moving head function and still stay on the servo control, then you can 3D print this head part with the servo. I've added LED lights. I'm not going to cover that in this discussion because that's, you know, that's just an option if you want to add LEDs. But if you just wanted to add the head servo, then you can just wire it off all the other servo controls that are happening. And I'm going to shut this down. I'm just going to hook in this Y cable here. Y cables and these servo extension cables like I'm using here, they're dirt cheap up on eBay. You should buy a bunch of them. They're very handy to have around. Well, I'm not going to be able to cram the head all the way down on because you would want to route your servo control wire. You would want to route it out through the hole in the bottom of your robot. And I'm going to take the time to do that just to demonstrate this, but you get the idea. If that wire had been routed out down there, then the head would wedge all the way down in there. I won't wedge it all the way down in because you know what I'm talking about. So that way when you make it walk, the head would move at the same time. So you could have that kind of an action. And again, you haven't spent much money then, because if you use the inexpensive China servos off eBay, you know, you're $3-4 a piece. Another couple of bucks for a little servo controller. Battery box, some Y cables, some extension RC cables. That's about it. So you can get into it real cheap if that's if money is a big issue with you, or you're not into programming. Now, if you do enjoy programming, then I would say don't bother with the servo controller. In this case, I just took a Y cable off the 2 servos that are down in the feet. If you can see, there's one on here, one over here. Just bringing cables up to the back. I have my main power on off. The batteries go on the bottom. You pull these 2 screws, this cap comes off. Then there's 4 AA batteries in there. That's weight for ballast to hold this thing down, but it's also a good place to put the batteries. But if you do want to program one, in my case, like I say, I like the Pololus. I paid $10 a piece for 2 of these, and you can normally find them in the $10 to $15 range on Amazon, both new and used, or you can pay full bore new at the Pololu website, which is $20. But you can control up to 6 things. It doesn't have to be servos. It could be relays, motors, lights, or you can use them as inputs too. So if you want to make an autonomous thing, you can do that. This little board down here, this is just a 5-volt reg that'll take low voltages and boost them up to 5, and if you're over 5, it'll regulate them down to 5, and it just makes sure that I have clean voltage going to the processor part of the Pololu. It doesn't control the servo voltage. This is just for the memory part. So in this case, I think we'd have to wire things up a little bit differently here. We would take, I'm going to go through the build picture, so a lot of this will make more sense to you in a minute. But I'm just plugging this in just to show you that this one could become fully programmable pretty quickly. This is going to be the 2 servos for the feet. I hooked the power into the board, the 2 servos to the feet. This next servo, let's hook that in here next. And then, like I say, because I decided to have lights, let's hook the lights in. Like so. And we're almost done. Like so. And then you can got plenty of room down in that bucket to tuck all the stuff. You can put your head on. The head is designed to have screws that will secure it once it's on there. So now it should be, I already programmed that chip, I believe. Here we go. So you can see it's walking. I had it set for taking like 3 full steps, then it should stop and do the head turn routine. And I'll turn it sideways so you can see the leg action a little bit better when it starts repeating the thing. A lot of uneven crap on this tabletop. But you get the idea. You can go either way with it. So as far as the build goes, or let's go ahead and start with what influenced this to begin with. I'm up on Thingiverse. And let's zoom in here. So if you wanted to build the original trash walker, just go into the search thing and put in trash walker and you can find it here. And I don't know how to pronounce the guy's name, but it's F-E-R-J-E-R-E-Z. And that was back in 2018. But there have been a lot of remixes of it. Whereas if you, for example, didn't like the head that I made for it, here's like an R2-D2 type head. There are a few other heads up there too when you go in and search for it. And I'll get all my files up there eventually too, depending on how fast Thingiverse works. So now let's get down here. Let's go to the build pictures. Okay. So we're going to start off with the feet, and we're looking at the bottom of a foot, or the main body of the foot. This is actually the bottom of the foot. And there's going to be 2 ratchet wheels, 2 little axles, and 4 rubber O-rings that snap around the wheels for traction. The axles actually end up sitting in these grooves so the whole wheel can move forward and backward to lock up. There's a close-up of one of the wheels. This is before I did any clean up. Normally I would take a flame to it and clean any little hairs that are left on here, but I'm basically showing the placement of the rubber O-rings. The axles I'm using are about 2 millimeter, And usually I'll just take old finishing nails and just cut them off, and then take a file and get the rough burrs off the edge. You just want it to fit in there and fit the axle of the wheel. No big deal. You can usually find something, even a jumbo paper clip would work. So this is the way they're going to be looking. This part is going, well, you'll see in the next picture, it's going to fit into the main body. I have a front and back on mine, so I actually put an F into this part so I could remember who's the front and who's the back. That's just a close-up of showing the wheel and the axle and how there's room for it to move depending on which way you want the wheel to lock up. This is going to fit right on that, and then I screw the two together. If you don't have screws, you could certainly just glue the whole thing together. This cutaway is where the servo is going to sit. The main body of the servo is facing out this way. This cutaway is for the power leads that come out of the servo, so they can come out. So here we can see the foot piece drops right down on top of those so they can glide. Then I'll put a screw through there. This is the front of the foot. And there's where I'm putting my two screws. Like I say, you can glue it. You don't have to screw it. This is just kind of showing the notches in the wheels versus the heavy-duty notch that's in the main body part. So when the wheel is rolling in a forward position, these edges are going to catch and lock. And when the wheel is pushed back, it can spin free. Just another picture of it. That's with that part off, so you can see how the servo fits, like I was talking about earlier. It's going to go in. And you know, the biggest problem doing with any projects and trying to share them on YouTube or Thingiverse with anyone is you can't just tell people that, yeah, I'm using the Tower Pro, the MG 90S. Well, unfortunately, you can find, at least when you start looking up on eBay and other places, at least I've come up with 4 different variations, all that say Tower Pro, all say the MG 90S, all different. Some of them won't even fit in here because the cases are just slightly bigger. Some of them are longer this way. Some of them have a different shaft. Some of them the shafts stick out further, far, you know, just all over the map. The last 2 that I bought for this project, because I wanted to add the head turn function, they look identical to these, but they're not. This one actually has a real ball bearing in here, and the ones that just arrived just have a brass insert. This has 4 screws that hold the whole thing together. The new ones that came just have 2. And the reason I'm telling you these differences is because the ones that I just got in are okay for doing the head turn, but they wouldn't be any good for anything else. They're pretty crappy. They run really slow, sound like they're binding a little bit inside. They're more jerky, they're not smooth. Very disappointed. Anyway, I've found up to like 4 different versions that all claim to be this, but they're not. They're different. So that's why I tend not to do too many servo projects on Thingiverse anymore or on YouTube, because it's too hard trying to tell people where they can buy the same servo I bought and haven't expected to fit the parts. So anyway, there's a servo horn that come with your servos. We're going to be using the very first hole. This is a servo mount screw that normally comes with the servos, which I'm going to be using to tie linkage in. But I ended up cutting off the rest of the servo horn. So I normally screw the screw in first and get it good, and then you actually would want to cut it off right about here on the next hole and get rid of that extra. So it's going to sit on here. This one's still a bit too long, so it needs to be trimmed a little shorter. That's going to end up hanging up, I guess is what I'm trying to tell you. And this is looking at it from the other side where the servo wire comes out. You can take a little drop of hot glue, or in this case I used a little drop of super glue, and kind of fold the wire back at an angle. This is the back of the foot, this is the front of the foot. That'll kind of keep that wire from dragging on the ground when you're putting everything together. Here's the leg part. This is going to go down in here, and we're going to screw it. I'm using some number 2 screws. You just need them long enough. If they're too long, they're going to hit each other in the middle, but you could always trim them off with some wire cutters if they were too long. So obviously I normally run my screws in all the way till it's too tight, then I back them back out like a half a turn or so, because you want this whole leg to be able to move completely freely, and there'll be a screw on each side. So these are the actual linkage pieces that are going to connect between the leg and the servo. So one's going to screw up here into this upper part of the leg. The holes will already be in the legs. And again, I'm using a number 2 and fairly long screw. I think it's like 3/8 of an inch long or so. And then it's going to come down to this servo and use one of the servo screws. And back on this other picture, here's a servo tester. I normally have the servo tester there when I'm setting these up because you don't know exactly where you want to put that horn. In the end, when this is they have a neutral position, so go ahead and get it in the neutral position, turn it on. This should actually be aiming upwards a little bit if you're at the correct position angle for everything to be working right. You're showing the 2 legs assembled. Next thing you're going to want to do is, these are here in America, these are called 632 screws. Number 6 is what they refer to the basic diameter of the screw, and the 32 is how many threads per inch that they have. But anyway, these are like 1.25 inches long or so. If you get one that's too long, you could always put a nut or a washer or something here on the inside. If it's too long, you'll see how the leg won't be able to pull together here in a second in the next few pictures. But once you know you've got the right screw, I normally put some glue on the threads and I screw it in all the way because I want this screw to stay solid. It's going to be acting as an axle or a hinge, if you will, for the legs. And I used a 632 tap and actually tapped the holes that are here. But if you don't have a tap and don't want to spend the $2 to go buy a tap, then you could just use your screwdriver or screw gun and run the screw in a few times and it'll cut threads. These pieces, which I called leg wedges, I could have come up with a better name, I guess, they're going to end up going inside the master trash washer legs, but they need to be threaded all the way through because they're what's acting as the hinge. So I want them to thread on and turn really nicely on the threads. So again, I used my 632 tap and just tapped them. But again, you can just run the screw in and out a bunch of times and even put some oil or lube on the screw threads so that they spin real nice. This is showing the bottom of the body. There's the big cutout where the 4-pack for the double A's fits in, and there's big slots for running your wires through to get them in there. I'm going to bring the wires up from that 4-pack battery. I go ahead and take a servo extension cable and just cut it short because you want to keep one in so you can plug into various things like a servo tester or a Pololu, and just interrupt one of the wires from the battery with a switch. In my case, I'm using the same slide switch I've used in all my projects. Basically, look for a switch that's got about 19 millimeters between the mounting holes, and then it'll fit in down there. Glue, I'm just showing my preferred glue. Actually, you know, the very best PLA, and these parts are printed in PLA, is the 3D Gloop. But 3D Gloop is kind of expensive, and if you don't use it all the time, it does tend to dry up in the tube or in the bottle. So this IP stuff, which you can find, I've done entire videos on showing it's almost as good as the 3D Gloop. It's plenty strong. It's better than using CA super glues for sure. But I'm going to end up putting some inside these leg pieces and then shoving those parts that we have threaded into the legs to hold them on to these nubs. And this is showing the batteries in the battery pack, and this bottom piece is going to screw onto the bottom. They hold the batteries up in from the bottom, just like that. And here we are, a quick shot at the top. There's a couple of pieces. There's the main top head piece. These are just screw eyes like you'd find in your hardware store. And this is a neck piece or servo or a head support, if you want, whatever you'd like to call it. I'll end up gluing a washer inside here because I'm using a magnetic way of holding things together. Here was a picture I took of the last two MG90Ss that just arrived that looked just like all the others but weren't. And I was showing that it just had this brass sleeve instead of an actual ball bearing. And a lot of these gears appear to be aluminum, and they it's like they're binding or something. It definitely doesn't run as smooth as the ball bearing one, and it ran slower. So in the case of the head turning, that was fine because I wanted the head to turn real slow anyway. Okay, so this is showing two different parts. This plate is going to go into the top of the body. The servo is bolted to it, and this servo ring part, and then I glue a magnet down into that. And then in this half, I glue a metal washer down in there, so this can stick on top of that, because this will end up getting glued to the head. And it gives you a way that you can position the head for photo shoots, or if someone grabs the head, you don't have to worry about them breaking the servo. So here's the bottom of this one that fits into the body. The servo just screws right in. Here's showing the top of it. This is the Pololu. There's the 5-volt regulator. I'm just showing where some of the stuff's going to slide down and mount. There are two holes that print for running screws in to screw that servo neck piece in if you decide to go that far. So on the head, I decided to use some 5mm colored LEDs here. There's a lens part that you can print translucent if you want and just glue in there, or you could print it in any solid color you want if you're not going to put LEDs in yours. There's no point really covering that part. And again, you could hot melt glue them in, or in this case I used E6000, which is a rubbery type glue. And this is showing how this part is going to now glue to this flange, like so. In my case, I had wires coming out for the lights, and then it just snaps down onto the head. So that kind of pretty much covers the build. So you can see you can do the build in many different ways. If you build it this way, where you actually still had pins and stuff coming out and control it with a servo controller, you're only spending, less than probably $10 to do the whole project. And only if you want to dump more money into it. The next thing you might want to dump money in is buying another servo and building the plate and putting a head on there. Or maybe you would want to buy the Pololu Mini Maestro and program one. Or perhaps you would be more into using Arduinos. If you do get into doing any sort of programming, the first thing you need to do is write down what the routine is that you want it to do. So in my case, I just grabbed a piece of paper and I started writing from 0, in my case from 0 to 16, what all the steps were. The very first thing I want the robot to do when I power on is for everything to home. I wanted the legs to center, the head to center, and all my LED lights to be off. So everything would home up. And then next thing I'm going to tell it to do is to move the servos for the walking. I called it right and left. I should have just called it forward and backward on my piece of paper, since both servos get the same signal. But I don't think we'll go into programming in this one or LED hookup, because that could take a whole video to explain how to do that stuff. And I actually have already done some videos in the past on programming Pololu, if you're into it. So there you have it. I think that's about it for the walking trash master. Like I say, I'll try and get the files up on Thingiverse, so if any of you want to 3D print and build one, or build any small part of it, you can. This is the folder, and the files are all hidden down in here somewhere. And I think that's about it. Just have fun with it.